All right, you can take it away.
All right, this helps if I unmuted myself there. All right, so I'm going to be leading this. Will kind of interject because there'll be some things that that'll be more observation based, and if any of the other scientists are on, I know I have a slide on pulsars and stuff. If anybody sees anything and they want to mention it, now is, or during the talk is the time to do it. All right, so preparing your observations. You always want to make sure, and you've probably heard most of these things already. These are things that we think are important and should be double stated. You should always talk to your support scientist in advance, especially if you're unsure and you might be having difficulties with, or you're uncertain about anything in your scripts. One thing Tony mentioned, you want to make sure you enable your projects and your project observers. You need them both in order to be scheduled. If you don't have one clicked, you won't get scheduled. Beware, not all receivers are always available throughout a semester. So I might have missed it. I'm pretty sure Tony would have showed you where the receiver schedule is on the DSS. But you should always check because you don't want to, there have been observers who will log in they've requested time for 2 receivers, and they log in and aren't sure which one is on the telescope currently. So you always want to make sure you know what receiver you're using and when it's going to be up. Oh, and there's the link to it. Yeah. Remember, B ranked projects end at the end of a semester, and so you only have that period of time to get your observations done. Prepping your scripts. So you want to make sure you put as much documentation in your scripts as you can. It's pretty easy, and nobody would tell me they don't do this, but obviously after a while you've kind of formed your scripts, you kind of just get into the habit of copying and pasting them, and you might not entirely remember what they are. I'm sorry, I probably shouldn't have brought that up. I really now you can see that. You want to make sure that if somebody else wants to use your script, they know what you're doing. And sometimes you can get in the habit of, you've used it so many times, you don't remember what certain things are. But if you keep things documented, you'll always have that, at least to help you out in the future. And you start any commented out lines, you put a pound sign, or I guess a hashtag, some people may call it, in front of that line, and that will comment it out. So that means when it runs, the script won't take it into account. When you're writing your scripts, all your frequencies should be in megahertz. Sometimes with certain different devices, it switches back and forth, it seems like. So for writing scripts, you always want to use megahertz. You want to make sure you check your RFI environment in advance. Mostly you should have done this when you kind of were also writing your proposal. It does have a section in there about RFI, but it also helps to check around that time, see if any RFI scans have been done recently to let you know if anything new has popped up or what the environment you might be looking at will look like. If you can, it can be helpful to calibrate at the beginning of your script and not at the end. Sometimes you might run out of some time towards the end with the only 5 minutes left and you need to finish, an on-off pair or something. And you don't want to have to end your script having not done a calibrator. So it's best to just do your calibrator first and then get it out of the way and then continue observing. At least that way you know you have it.
I comment on prepping scripts a little bit. So with your group leads over the past day, you have written a few different scripts and you've probably done it in different ways. You can start with the observer guide for your script. We are also creating quick start guides across different frequencies that show an example observation from start to finish for, let's say, H1, etc. But you can also, like Amber said, go in and find old scripts. Those don't necessarily have to be your old scripts. If you know of a project that used a similar setup, you can find that area in Astrid. And so that's fairly common for people who want to see what other observers did, what their setup looked like. If you do this, though, be careful because you do have edit access for those old scripts and for other people's scripts. So make sure that you're not changing anyone's scripts except for your own. Use them only as a reference.
And then also, as Will noted about I can't remember if I plugged the quick reference guides yet or not. There is at least one that's completed, and it is on the website. I think Dave put it on the Observer page, and it's like at the bottom, and I think it's like quick reference documents, and it'll take you to a page. There's only one there right now, and it is H1 position switching, single pointing. There are other ones that are done. We're just trying to do observations for them. So they're not listed yet because the observations haven't been done for them. But if you want to take a look, that at least that one is there, and I did share it with my group at least so that they would be able to see what a standard script and stuff looks like.
Here's a question. Is it possible to write scripts in a separate text editor and import to Astrid?
Yes, that is, you can use whatever text editor you'd like. Sometimes it's just easier to do it in Astrid in the beginning because Astrid obviously highlights certain configure and stuff like that, whereas your text editor might not do that. But you're more than welcome to do it both ways, or either way, whichever way makes you're more comfortable with. Pointing and focus scans, choosing a pointing calibrator, you should probably use a GBT pointing cal, and there should be one for every receiver for the correct band. If you can also choose a source that is a VLA flux calibrator, and this allows you to check your calibration when you point. During high frequency or poor weather conditions, you can actually relax your heuristics, which is under tools, options. When you're in the Astrid data display, you want to go to tools, options, and then a pop-up will show up and you might have to scroll over to see heuristics. But then you can set the standard to relax. And we also recommend, obviously, for high frequency, you do that as well. And then I think that next image is just, they're showing where, I don't know if we went over it, how to enter your own. On that same tab, if you scroll over, you can send your corrections and stuff manually to the telescope if you need to.
That is mostly important for higher frequency observations typically.
So before your observations, you always want to make sure your scripts are ready and they have been validated before you enable your project. I've had a lot of people who just want to get it scheduled, and so they get scheduled and they enabled everything, but then they haven't written their script yet. So you should not enable the project if you don't have a script written, because you could be dropped in the next day or two, depending on what the schedule looks like, and you don't want to be rushing and trying to make sure you have a script that works. So once you've written your script, you can go ahead and enable, but I wouldn't suggest doing that beforehand. You always want to make sure that your LST ranges are correct, so that your observations will be scheduled when your objects are above your minimum observing elevation. If you put in something wrong, Tony, takes all that information that you gave in your proposal. So you just want to make sure all of that's right and makes sense. You always want to keep your blackout dates up to date at all times. And maybe even check, if you have more than one person on a project. I've already had a project where I was not enabled, I was blacked out, but a fellow observer was not. But they were not available to observe, so I had to actually go in and do the observation. So you kind of maybe want to also check with your collaborators and make sure they're keeping their their blackout dates and contact information up to date. You want to make sure your contact information is always up to date. If it's not, then obviously the operators can't contact you, and that will be a problem. You will most likely just lose that time at that point. Test remote access of the telescope. So yeah, you always want to log in early and make sure that you can log into all the systems and that your internet connection is working and everything. Make sure you remember the date and time of your observation and show up for it. We do have certain people who are infamous for observer no-shows, where their lives are very busy and they tend to forget. This is a little bit annoying for the operators, and they will call you, but I mean, they will do that, but you don't want to be known as the person who constantly forgets their observations. And this originally said 15 minutes, but I was always under the impression you should always try to log in at least 30 minutes before your start time to make sure you don't have any issues. This way you've also connected with the operator, they're aware, and as soon as the person before you is done, if you're already logged in and everything, the operator can do the receiver change or whatever they have to do, which if it's just a standard receiver change, it takes an operator about 4 minutes at most to, I used to try to test myself to see how fast I could do a project change. So they can be done very quickly. So if you've logged in and you have everything ready, you could be started within a minute or two of your observations. So that's why it's good to log in ahead of time.
Another point on that, sometimes the observer before you will be running long blocks and they won't have time to run another block before the end of their observation. So I've had many times before the project before me say, I can't do another scan, please give my time to the next person. And so it's a way, if you're logged in earlier and ready to go, sometimes you can get some extra time there. Amber, could you pop back one slide too? Just on the scheduling point, Tony mentioned that the telescope is scheduled 24 to 48 hours in advance. So you will get an email as soon as your project is scheduled. And again, that does not give you too much time, a day or 2 days in advance. So if you do get an email that mentions the GBT schedule, it is very likely because your project has been scheduled. So just be extra attuned to that.
All right. So when you're observing, so I'm going to say this point, and then there's a caveat. Don't use someone else's account ever. You should never be logged in as somebody else, even if their session is already open. And you're observing from the same location. You're not allowed to use someone else's account. And I do believe that this can actually get your account banned, or at least I remember it could at some point if we found out you were using someone else's account. The caveat is we understand for observer training and the way we have everything set up, and because everything is remote, that you will not, that obviously for these 2 nights you had to use the account for whoever was your project friend. That is understandable. Nobody's going to get upset with you for that. That was how we had to do it. However, after this, you should never be using another person's account. Even if you've told the operator that it's you should not, don't do it. Simple enough. Make sure not to duplicate session numbers within a project. This usually falls on the operator. However, they are human and they can mess up as well. They should reset your scan numbers to 1, and you should have updated your session. So if you forget to update to session 3, and they have done their job and reset to 1, that might cause you to start duplicating over project numbers in GBT IDL. And whereas all that data can still be restored, it makes your life a lot more difficult. And sometimes the operator can just forget to change the scan number, which in that case it shouldn't be a problem, but it's just something to keep your eye on. They do quite a number of steps to do a project change, even if they can do it quickly. You should always be checking your GBT data in real time. You can use GBT IDL or Astrid. I personally use GBT IDL, but you'll find as you do more observations, you'll find your own way of doing it. But I would not just start your observations and then walk away. You definitely want to make sure that everything, because there might be something even the operators can't see, or that isn't flagged, but it doesn't look right to you. And so you always want to make sure that you're checking your data, especially in the beginning when you first start, and then periodically throughout your observations. Operators, yay. I'm going to assume I put this in here. There was a time where for Spirit Week, the operators decorated the door and we put a bunch of schematics, and you probably can't read a lot of these, but some of these all of these are random, I don't want to say dumb, but not somewhat annoying questions that the operators constantly get. And so we printed those out and taped them to the door because we thought it was funny. All right, so you've all heard my soapbox from yesterday, but now I get to do it again. Be nice to them. They're, some of them they've been there a very long time. They're working 12-hour shifts. Their job is not just to take care of the GBT, or that is their main priority. They're also taking care of every other telescope on site. They're technically also site security. So if something's going on, somebody's trying to come in the building, that's especially on a night shift, that's their responsibility. So, they have a lot of things going on. They could potentially have a lot of things going on at once. And so, they just, you always want to try to be nice to them. They might have there might have been a lot of problems beforehand, and, they're human too. The operator will always tell you if things are ready. If you interrupt them to ask, it's just going to take them longer. Like I said yesterday, some of the operators are hunt and peck typers, so they type with one finger. I showed my group last night that a very good way to tell if, like, so when you request to start and the operator says, all right, hold on, or whatever, and you want to see, you're like, oh no, this is taking too long, something must be wrong. If you look at your status window, if you ever see that the antenna, where it said antenna and then it has ready, activating, if you see that say activating, that means that the operator is moving the turret, they're moving the boom. So if you see something actively happening on the GBT, then that's positive that the operator is still in the process of doing something. And so like this says, you know, if they're in the middle of doing something and you keep messaging them, well, what's going on? It's just going to take them longer to have to fix your problem or to get you started. Unless your project is operator run approved, they cannot run your project for you. They will, if it's in the middle of the night, they will monitor it for you. They'll watch it. And if there's an abort or something, they will call you, but they will not run it for you. In order to get your project operator run, there's quite a number of steps, and I think at least Preeti has gone through this. I'm her project friend, so I know. But you have to go through a number of steps. It has to be approved by the operators that they feel they can understand it, because it's probably good to note that I think only one of the current operators has a background in astronomy. So for a lot of them, they might not necessarily understand what your science is or know how to fix your problem without you there. Be clear and specific about your issues. Specify what your exact error messages you're receiving. A good resource is to ask if the warning or the error is something worth worrying about. I kind of went over this yesterday. You know, they have like, their message screen is much fuller than yours. So if you're seeing a specific message, you want to make sure you tell them. And one of the quotes on that door that you couldn't see was a very specific quote where I had an observer when I was an operator who kept asking me to call Ryan because Guppy wasn't working. And I said, well, what's wrong with Guppy? And they wouldn't tell me. They just kept saying, Guppy, there's something wrong with it. And so after several minutes and just getting frustrated at 2 o'clock in the morning, I just called Ryan, and it turned out it was something simple, that they were looking at the wrong screen or something. And I could have told them that if they had just explained what their problem was. So even when I say, you know, they're not necessarily astronomers, they are very knowledgeable at the same time. And so that, you know, just make sure you can explain yourself or explain your problem, and they can usually help you. They are not there to fix all your problems. No, they aren't there to fix any and all problems that happen on observatory property. This is more into effect if you're there. However, they should be the person you call. If you see something on site that you don't think should be there, like we do have people who try to go into site and hunt and things like that, they should be the person you call. They may not be able to fix the problem, but they'll know who to contact to fix the problem. I think one night I was taking a walk and I heard the alarm going off over at the school. I walked up to the phone outside the inside the building doors and called the operator and just let them know, and then they got into contact with whoever they needed. And if you ever get to go to site and you forget your key card, you can always, all you have to do is there's a phone right inside the door. You type 2341 and it goes right to them. And then if you ever actually need to call them for observations, their phone number is, I should have probably written in here, 304-456, and then it's the 2341. Talk and draw. All right, this was my soapbox. You all heard this. Don't have a private conversation and talk and draw. Just don't. I explained to you how this works. Like I said, create a new group. Some operators are very good about telling you to go into another chat. Others aren't, and they'll just sit there and stew about it. So just, you know, be polite. If you're going to have a conversation that involves the operators, that's fine. Just don't, you know, like I said, it's the boy who cried wolf. They listen to that horn honk enough, they're going to ignore it. And don't hit that get attention button. That get attention button should not exist, but it does. I can't make it go away. Never touch it, ever. That is the quickest way to just make an operator very annoyed. For receiver changers do take time. And you should, and you do not know what receiver the observer before you is using. The operator is aware, though, of what they pretty much mark, at least I did, always marked out what receivers were next. So don't just assume that when you log in, like I said earlier, you want to log in early. You don't want to log in like a minute before and expect that the operator is going to have that set up for you the minute your time starts. When you wrote your proposal, you put in overhead, and it's always included that you should assume 15 minutes at the beginning of every observation for operator setup, they're actually given that time. So you know, they never take that long. I don't know if I've ever had a setup unless there's a problem that lasted that long. But you need to plan for knowing that they're going to have to switch receivers and stuff like that. Switching between Gregorian receivers can take about 2 to 4 minutes, depending on where it is on the tiny turret that we use for the receivers. And extending and retracting the boom can take up to 10 minutes, or 8, I would say probably 8 minutes is about how long it takes. And they cannot change the prime focus feeds on the fly. That requires a full maintenance day, so you can't say, oh, well, I wanted to do 820s up tonight, but I want to do 342. You can't do that. That's impossible to do on the fly.
Amber, a question came in asking, what are the typical overhead times? So this depends on the frequency and the receiver that you're using. The higher frequency receivers have much higher overhead. They can be 50% of your time just dedicated to overhead. And then that shrinks a lot as you move to lower frequencies and you don't have to point nearly as much. So all of the estimates for those overhead times are in the proposal guide or the proposer's guide.
Yep, and like I said, getting started, the longest thing is going to be if they have to retract or extend the boom. Other than that, the operator can do a project change within, like I said, maybe 4 to 8 minutes at most. So, and like I said, you can always check to see if they're doing something by checking your status window. After you're observing, you should try not to run over your scheduled time. We had an example last night with my group. They needed 2 minutes extra time. So I said, well, you need to ask the next observer. So they logged in, I believe it was actually Will, and they asked Will if they could have 2 minutes over. And that's up to the observer and the operator if they want to let you do that. Obviously the observer has to be okay with it too. But you should try not to go over if possible. You should try to have it set so that, like Will said earlier, if you can't run your second on-off scan before the end and you're going to go over by like 10 minutes, then you need to stop before you do that first on-off pair. You just want to make sure you're not taking time from anybody else. And then if you do have to go over periodically and you have to go over by a minute, in most cases, if you're polite about it, other observers will be polite about it as well. Submit observer comments after your observations. If you had issues, we need to know about it. We can't fix them if we don't know they happened. And so the operators have logs. They'll tell us when something bad happens, but if you have something that you're concerned about and you just, it wasn't something you thought that should concern the operator, you need to at least tell us about it, because whereas they may not, if you don't tell us about the issue or them about the issue, we don't know to fix it. You always want to analyze your data in a timely manner. I'm sure we're all guilty of having a data set and then at some point, well, maybe you guys haven't observed yet, but I'm sure even most of our staff scientists can tell you they're guilty of, maybe forgetting about a data set and letting it go too long. You should always try to analyze your data in a timely manner, because you want to make sure that, before your project ends for the semester, or before, we get into the next semester, you want to make sure that all your data looks okay. Because if there was a problem with it, you need to tell Tony, and Tony would need to, either give you more time. But if you wait too long, that's not necessarily going to be an option. And then you should always check your previous data, even if it's just a quick check. So if you're doing observations, if you did your first set of observations, before you do your second, you need to check the first ones to make sure that everything turned out okay. Because if they didn't, you need to adjust for your next session. Even if it was your last observation, we still want to know if you have any issues or any problems. Because that might cause, like I said, cause an issue for someone else, and we can't fix it if we don't know about it. All right. It's now just going to kind of go over some quick sections, quick notes about certain forms of observing. So H1 observations and mapping. I always say you should always do a pointing scan focus before taking data, because in my mind, even if it's not entirely necessary because of the size of the L-band beam, it's almost a sanity check, because if something's going to go wrong, you're going to see it most likely in your pointing scans. But some people will say you can just skip this and you don't really need to do it for L-band. I usually say you should do it, like I said, for a sanity check. You should always take a short spectrum on a known object to make sure, again, another sanity check. I always prefer to still do the auto peak and point and focus. Check that maps starting and ending positions are correct. So essentially, if you've started running a map and your time runs out and now you're on row 18, if you run that script again, that script's not going to remember that you stopped at 18. So you're going to have to go in and edit your script and tell it to start at row 18. It's not going to remember. It's just going to execute and start at 1 again. The GBT point spread function is a Gaussian, and so it shouldn't be a square or a circle. Pulsar observing. I'm not sure if Ryan or Andrew are here. I kind of wasn't sure about this one. I kind of went over it with Ryan yesterday, but do not rebalance between a calibration scan of a noise diode and the science scan on the pulsar of interest. And make sure that the Vegas.fold par file parameter and asterisk points to the correct file on disk. I had to read that exactly because I wouldn't unfortunately be able to help you with that beyond this is what Ryan said I should put. So if anybody has any questions, you can talk to Ryan or Andrew. Weather issues. So I think Tony went over the weather, correct? About all the...
A little bit, not so much about how slew rates decrease, I don't think.
Okay. So as I think I also mentioned it yesterday, as when there's a lot of snow, the operators are going to halt your observations because they want to dump the snow out of the dish. We don't want like thousands of pounds of snow sitting on our hypersensitive dish. So, and depending on how bad that snow or ice is, they might either just dump the telescope once, or they might actually stop you so they can put it into what we call survival position, which will prevent more stuff from building up on there if we can. In cold weather, so like I said, minus 17 Fahrenheit, the slew rate is cut into half. It's what we call warm and cold rate. This is something you should be aware of, especially in between December and February, because it does happen quite a lot, especially during the night and in the morning. And your rate the fastest rate the telescope can slew will be cut in half. So you need to, if you're doing things at a certain time, all your observations will still execute as normal, unless you're really close to the keyhole, which gets substantially bigger in this case. You just want to make sure that if you have things very precisely timed. If it's too cold, it's going to take longer to do certain things. The telescope should be stowed for sustained wind. If it exceeds 30, if it's a gust of 35, or sorry, if it's sustained 35 miles per hour or higher, the operator will probably will stop you, and they have to go 15 minutes without having another gust or another blast before they'll let you resume. And then if it ever reaches above 40 miles per hour, they're going to stop you. They're going to put the telescope in survival. And again, they have a little alarm on there that counts. As soon as the alarm goes off, it starts a timer for them so they can see when it's been 15 minutes or not. The operator only stops for wind when it reaches those limits. It says they will not warn you if the wind will affect your, they can't tell you if the wind is going to affect your data. They will usually try to warn you though if the wind speeds seem to be getting high, if they seem to be peaking, and especially when it's hitting that 35 mile per hour, if it's just a few gusts, they might let you know. I know my way of doing it was if it gusts at 35 miles per hour 3 times within 10 minutes, then I would halt for a little bit. But they can't tell you necessarily if the wind is going to affect your data. You're going to have to be able to take a look at that. You should keep it in mind. It depending on what frequency you are, the weather could affect your observations. And if you think that it's going to affect your observations and you're worried, you can give up your time. And when I say give up the time, just means at that moment they'll stop and Tony can give you your time back at a later date. And when the telescope reaches minus 10 degrees Fahrenheit, and it does, telescope will be shut down completely and will not be moved until the temperature reaches above 0 degrees Fahrenheit. Other frequent issues, blanking. If a lot of your data is being blanked, that usually means your switching frequency is too small. There should be an observer's guide table that tells you what your minimum SW per value should be for each frequency switching mode. And I thought I heard Will chiming in there. And if you're not reaching your desired sensitivity, You should remember effective integration time does not equal observing time. And then there's a little calculation down there. I think Dave or Natalie or somebody might have covered that. And that's it. Unless you guys have, oh, I just realized that was up in the corner. You guys have any other questions or anything that you're concerned about or worried about when you have to observe by yourself? Now would be the time to, I mean, you can always ask us in private if you want to, but thank you, Will, for putting the phone number in there.
There's a question here about any recommendations for the minimum strength of calibration sources.
Will, I'll let you handle that one.
Yeah, so again, I think that varies depending on the frequency. For Argus, if you're going to OOF, then your OOF calibration source needs to be typically, I would say, 10 Janskis or so. And as Dave was mentioning, there were only 6 or so sources at W band that are at that strength. So there are specific catalogs in Talk and Draw or in Scheduler and Skyview that are the calibration sources for different bands. So I think if you look at those catalogs, you should be pretty good. I haven't run into any problems except at the very highest frequencies, where again for Argus you want something around 10 Janskis for the OOF and on order of several Janskis for pointing.
Oh, I guess maybe I could, Ron, did you want to say something?
I was going to say, when we do flux calibration, lower frequencies for pulsars, I usually recommend about a Jansky or two, even down to half Jansky is fine. You don't actually necessarily want to go too strong, because if you're a large fraction of the system equivalent flux density, it can make balancing for your on and your off scans a little bit difficult. But there's a standard list of flux calibrators that we tend to use that are part of the PS Archive package and have all the spectral characteristics very nicely defined, and are very easy to calibrate against. So there's a few of those that you can find in the catalog that I can provide.
And so then I was just going to say, I realized that all of you have only actually probably met one operator at this point, which was Greg, who was our operator last night. Just nice to know. So there are 6 operators, and then there's an operations manager, and then the head of operations. Head of operations is Bob, excuse me, is the head of operations is Bob Anderson. The manager, who you might hear from, you might periodically see, if you had a problem, he'll get copied on, is Pete Chestnut. And then the 6 operators are Greg Monk, who was your operator last night. And as I like to tell, I told my group, Greg has been here. I think he's the longest standing operator. He was the operator when the 300-foot fell. So he's been here for a very long time. Dave Rose, I usually say he's kind of like the head operator. He's the one that all the other operators go to, or is the most knowledgeable and maintains all their documentation. There's Tyler Heiss. He is one of our newer operators. Rob Taggart, who is actually my replacement as an operator. Oh gosh. Brandon Moore, he was actually used to be one of our head painters, and now he's an operator. And then we just recently hired Aaron Lovato, and it will be his first time, I think this weekend actually. To train an operator takes about 3 to 4 months before they can go solo. So he will be starting this weekend. And when you log in, you just have to ask who they are, and they'll let you know. Some of them are more sociable than others, but it's good to at least know their names. And I guess you saw them kind of in the Astrid window, but that's your little bit of background about them.
So the last question in there is right on that point. What kind of training do operators have? And as Amber said, to train a new operator takes months, it's almost an apprenticeship where they will join a current operator for their shifts for 3 months. And then whenever we have new observing modes or operator run projects, they'll get training sort of ad hoc on those.
Yeah, and it's good. So how it works is that the operators work 12-hour shifts, and their shift schedule starts on a Monday at 7 a.m. So then they'll work 2 7 a.m. shifts. then they work 2 7 p.m. shifts, and then they actually have 4 days off. Technically, it's only 3 because they sleep for most of the first technical day off, and they cycle like that for 8 weeks. And then they go into what's called office duty. So if one of the operators is ill, has to be out of town or something, there's always a backup operator to cover cover for whoever is there. But they're like the one thing in the GBO that they were like the only people that still had to work in the building when we shut down for COVID. They had to be there. There is always an operator there. There's always somebody in that building just to be safe. But they have their own ways of working around things, and they all have different backgrounds. One of them is a couple of them are ex-military. One of them is an astronomy student. I'm not actually sure what the other 2 do, but they're all different. They all have different backgrounds, but they all kind of go through that same training.
So the last question, because I think we're cutting into Ryan's time a bit, is in the scheduler and Skyview system, is there any velocity information for sources in the standard catalogs? And I think that the answer for that is no, but I can check.
Yeah, I'm not sure about that either. Also, my chat doesn't seem to be updating because I can't actually see anybody's questions.
That was a private question.
Gotcha. Okay, yep. Thank you. I was just like, I'm missing something here.
So thank you very much, Amber, and for everyone for your questions. I will end the recording.